Part 6.2 of Lab 20, the chopper circuit, is a really fun circuit. Okay, so chopper. Um, Actually, old-fashioned oscilloscopes used to work this way because there was just one electron beam that could draw across the screen, and then they had to alternate back and forth. If you want to look at two signals at the same time, there were two ways. They had alt or chop. So alt was they would sweep across the screen looking at signal 1, channel 1, and then they would sweep across the screen looking at channel 2, and then channel 1, and then channel 2. That's fine if you can go back, if the trace rate is very fast. So if you're like tracing back and forth faster than the eye can detect, so every other trace is input 1 or input 2. But if you're tracing slowly enough that you want to be able to see both inputs on the same trace, and they need to chop the input signal, chop back and forth between the input signals to what the electron beam is drawing. So this circuit, I've kind of redrawn it a little bit from Tom's version. So we have two switches, and they are complementary switches. So switch 1, if it's on, then switch 2 is off. If this is closed, this is open. If this is closed, this is open. So only one or the other is open at a given time. So therefore, it's safe to wire the drain outputs of these two switches together because only one will be closed at a given time. And then you send that to the scope. And then we have the source inputs of these two. One of them will go to AWG1, and one of them will go to AWG2. And I made one of them, I can't remember now which is which. I made one of them a triangle wave and one of them a sine wave. I think I might have done the reverse of what I drew here. One of them is a sine wave, one of them is a triangle wave. And they're both like about 50 hertz, 49, 50 hertz. They're slightly different, so it looks more interesting. And then I need, so this is pin 16 is S1, pin 4 is S3. So if this input is high, then this is connected and this is disconnected. And if this input is low, then this is connected and this is disconnected. So what's going to toggle back and forth? Now we only have 2 AWG outputs. If we had a third AWG output, it'd be fun to use that. But it turns out there's this feature called patterns on the EE board and the waveforms software. So I used patterns to do a digital logic output, which goes back and forth. I thought it would be between 0 volts and 5 volts. It looks like it's actually between 0 volts and 3.3 volts, but it's good enough, it turns out. And I had this go back and forth at a kilohertz. Okay, so then we're going to switch back and forth. So if we look at this, and this is scope channel 3. And then we have scope channel 1 looking at this, and scope channel 2 looking at this. Yeah, and scope channel 4 is looking at this thing. So this is scope channel 4. Okay, so here, scope 4. This is scope 3. And then this is scope 1, and this is scope 2, okay? So let's look at what we get. And then I think the wiring is not very interesting on this. So, AWG1 is this blue wire that I'm wiggling. So that's going into S1, which is pin 16. You can see that. Then AWG2 is this blue wire I'm wiggling. That's going into S3, which is pin 4, so you can see that. And then, let's see. I have scope channel 1 directly monitoring AWG1. I have scope channel 2 directly monitoring AWG2. Scope channel 3, this little blue wire is connecting D1 and D3 together. So it's connecting pin 1 to pin 3. And then I have scope channel 3, which is this green wire, this green wire. It's looking at pin 1. It could look at pin 3. It's the same thing. And then I have scope channel 4 looking at pin 15. So scope channel 4, yeah, it's this wire, is looking at pin 15 up here, the one over from the top left. Whoops. And then also connected to pin 15 is, well, let's see, I would have to zoom out for you to see it. Maybe I'll try to do that. It is this digital output 0. So maybe I'll show you that because we've never used that pin before. It is up at the top right corner of the EE board, and you see you see digital pin 0 here. Okay, so then I'll show you how I set that up to work. I guess I always start by showing you the power supplies. So we have VCC, VP plus, and VP minus. That's 5 volts, plus 9 and minus 9. Then we have wave gen. So not synchronized, 2 channels. So channel 1 and channel 2, AWG1. AWG1 is a 50 hertz sine. Yeah, I guess I drew it backwards. AWG1 is 50 hertz sine. AWG2 is a 49 hertz triangle, and they're both 5 volts amplitude, no offset, whatever. And then patterns, this is a new thing. Patterns, I have digital IO0, pin, digital IO0, output PP, I assume it means peak to peak, I don't know. And type clock 1 kilohertz. Okay, so that seems to work. I was hoping to go back and forth between 0 and 5 volts. Instead, it goes back and forth between 0 and 3.3 volts, but close enough. So the green trace, which is scope channel 4, is looking at that digital signal. So you can see it's a square wave. It goes back and forth between 0 and 3.3 volts, and it is a kilohertz. I guess you can tell it's a kilohertz because we have 5 milliseconds per division, and it does its thing about 5 times. Then, if you look here, if I turn off channel 3, then you can see the yellow trace, channel 1 of the scope, is a sine wave. And the blue trace, blue or cyan trace, channel 2, is a triangle wave. So one of them is 50 hertz, one of them is 49 hertz, so they're kind of similar, but they scroll back and forth. And channel 3 is fun to watch because it's going back and forth between being the sine or being the triangle. It's like multiplexing back and forth. And you can see that more clearly if I turn off the yellow and blue traces. Then that's really neat. You'll see the magenta trace. The magenta trace is like really just one oscilloscope trace, but it's showing you what's happening on 2 traces. That's kind of neat. So you can use that one trace to show you what's happening on 2, and it would be a better effect if it didn't draw the vertical lines. So I think when you do this with an oscilloscope, it's smart enough not to draw the vertical lines. So then you would just see the 2 traces kind of with little alternating segments, so your eye can't even detect it. I mean, we could also turn off the green trace, I guess. Yeah, so then you kind of see the 2 traces at once. It's chopping back and forth between the sine wave and the triangle wave. So I think that's pretty cool. And again, if it drew the non-vertical segments only and didn't draw the vertical segments, it would be more impressive to look at. Okay, so I like that. I think that's everything there is to see for the chopper, part 6.2. So then, in the next video, I will attempt to build 6.3, which I failed at last year, but Joe's succeeded.